Welcome and thank you for coming to this session. A session we have titled Digital Decoupling, 8 Lessons Learned Deploying Event-Driven Enterprise Applications. My name is Gonzalo Perez-Prim. I'm part of the technology, strategy and advisory team at Accenture. I have more than 20 years of experience in consulting. I have worked across more than 12 countries, working mostly as enterprise architect. These days, I'm mainly focused in digital and ERP strategy. I have worked for consumer goods, services, and oil and gas, among other industries. The objective of this session is to present 8 recommendations useful for deploying event-driven applications. These recommendations are part of our approach for building event-driven architectures. We have named this approach Digital Decoupling. This session is split in 9 parts. As a starting point, we will explain the context in which these recommendations could be applied. Then, we will describe in more detail each one of these 8 recommendations. First, let me set up the context. We are living in times of disruption, where enterprise and organizations are suffering tremendous changes. Traditional industries, such as automotive, retail, advertising, or publishing, are completely disrupted. It's not merely a question of returning to their leading positions. These companies are mainly focused on rethinking their business to survive. What is exactly needed to survive in each day more chaotic environment? How living systems adapt to their environments? Plants do not require a brain to survive. Plants adapt themselves to sustain, reacting to stimulus or events happening around them. They reshape their roots and leaves to obtain the maximum sun and water. As plants, enterprise could also be considered as living systems. Enterprise are merged, carved out, outsourced, or divested. They also transform themselves, creating new business models. Enterprise do not need an orchestra director, but to decentralize their capabilities and quickly and autonomously react to changes or events happening around them. To react to changing conditions, enterprise need an architecture enabling them to detect events. As at Accenture, we see EDA as a way to unlock and share data from multiple systems, to sense events so intelligent decisions can be taken in real time. We have observed that once conditions have changed and the company has been disruptive, most of them are not able to recover, since most companies were orchestrated to always follow the same rules and not to react to changes. For this reason, we have created Digital Decoupling, an approach for combining strategy and tools to reap value as soon as possible from event-driven architectures. Its aim is to develop, deploy, and operate products in an independent way to increase agility and decrease time to market. Unfortunately, monolith applications make it difficult to react to changes. Digital decoupling tries to incrementally break down monoliths to modernize them in a way that IT changes feel small. Digital decoupling makes the use of real-time event streaming, microservices, analytics, cloud-native technologies, and DevOps. Applying these technologies leads to an scalable, flexible, and resilient enterprise IT. An enterprise IT that gives companies the ability to continuously innovate and implement differentiated business capabilities on top of legacy systems while reaping value from their enormous wealth of accumulated data. In summary, digital decoupling allows us to extract functionality from existing applications, add digital capabilities such as artificial intelligence or machine learning, while at the same time reducing technical debt. Now that the context is clear, we navigate in more detail through each recommendation. The first recommendations that we are going to see is contract-based data sharing. To implement contract-based data sharing, it's recommended to design first each contract API specification. Contract-based API are not new. It's a concept frequently used by agile teams to work and exchange data with more autonomy, since they don't have to worry about its implementation. As EDA, contract should combine API and events. Contract specifications should be bounded to a specific context. For instance, if we consider a product entity in the context of a CRM application, normally a product is a finished good, but it could be also a raw material or semi-finished good if we are talking about the context of a supply chain, supply planning app. So a contract API cannot be confused with a canonical model. In fact, we recommend not to use canonical data model since it tries to produce a single version of truth disregarding the context. To summarize, enterprises are subject to changes. They have departments, are sorted, division merged, carved out, and sold. So we need to forget the concept of API as interfaces and start thinking in terms of contractual agreements. The next point or the next recommendation that we're going to see, it's how to track business changes. Events happen both inside and outside the company. Outside, events happen at social media, product launches, key holidays, entertainment, and weather changes. Inside the company, there are business events happening at monolith applications. To track internal events, we recommend sharing data using a method called change data capture of CDC. The change data capture is a tool for extracting incremental changes from the database from the monolith applications. The third recommendation that we are going to tackle is not to underestimate the importance of latency. Latency is one of the key factors to watch in an EDA. Enterprises rely on an enormous pool of data to extract insights. One of the key characteristics of digital decoupling is extensive use of cloud-native technologies. To avoid latency between CDC and the event stream, where we restrict changes, we need to properly size the network bandwidth. However, most teams used to request and reply architectures over HTTP. They believe that merely increasing network bandwidth is enough. These connections are not like a web page. They are open connections which stay alive, sending and receiving high volumes of data. Data volume is much higher and connections permanently open. In summary, due to the volume of data and the connection type, we recommend to minimize distance between change data capture locations and every stream to minimize latency. The fourth recommendation is using contract-even specification standards. There are many benefits of adopting a specification for contract-even API. They not only help to document API, but also have tools which simplify event deployment and event stream. We recommend two specifications, Cloud Events and AsyncAPI. Cloud Events is a specification for defining serverless events, a specification for events shared among several systems. It is adopted by companies such as SAP, Microsoft, Oracle, Google, or HUD. The other specification recommended is AsyncAPI. It describes event-driven API in a protocol-agnostic way. It is supported by many protocols such as Kafka, WebSocket, HTTP, and MQTT. And a specification supported by Solus, Moonsoft, Slack, TIBCO, Salesforce, SAP, Postman, Red Hat, among others. It can be easily combined with cloud events. The fifth recommendation is to include a schema registry as part of our EDA. Schema registry is a component that stores the event context schema. It's not only used for defining the contract. It can only be used to assist in the data deserialization and serialization. This schema helps in reducing the event payload size. There are three possible schema registry options. Each option is valid for using protocols such as Abro. Abro, it's a serialization system which reduces event payload and allows to validate the context using a schema. What are the possible options? As we said, there are three possible software that could be used or we recommend using as a schema registry. The first one is Confluent Schema Registry. Confluent Schema Registry, it's a free schema registry which provides the basic features for data deserialization and serialization. The second one is Apicurio, which is a tool that combines Contract API Studio and Schema Registry. And this tool has built-in support with Microsoft, which is an API mocking tool which can help us to test our contract-first eventful API. Finally, Solus has a pub sub which combines this content with more features such as a catalog portal so you can find events to subscribe. There are several the sixth recommendation is to use low-code tools. There are several use cases where we need to combine from events from different sources or to enrichment with data. Event processing is a method for analyzing and enrich streams of events. To process events, there are several technologies. However, these technologies need specialized programming language skills such as Java, Python, SQL, Kotlin, and Scala. To avoid requiring an advanced and inexpensive programmer, we recommend using low-code tools such as Node-RED or Eclipse stream sets. Node-RED is a visual programming tool with many official and community plugins. These plugins support event streams such as Apache Kafka, event processing such as Apache Flink, or Kafka streams. Finally, a specification such as AsyncAPI. Eclipse stream sets is an open source for catching event streaming application, for creating them visually and interactively as it was an Excel stream sets. The seventh recommendation is to use publish and subscribe. Our corporate environments, most people tend to overlook the importance of using publish and subscribe patterns. Many people, especially those that come from traditional integration background, do not understand events, and they always design it. They don't understand that events should be designed to consume it by several applications. You don't know who will consume your services. So we should not use routing unless it's strictly necessary, and we recommend using publish and subscribe pattern instead. Our final recommendation is to use choreography. Choreography is the best method to coordinate several actions happening at different systems. When an event is executed as a system, something needs to happen at a different one. The coordination happens as a ballet. Each dancer knows the movement which needs to be executed. Each dancer knows its choreography and perform it without having a director. Dancers are like plants. Plants' root and leaves act independently, and there are a common choreography. For simplifying this choreography, we recommend using real-time monitoring tools as a Prometheus and Grafana, and also to reliably handle enterprise events, we recommend to implement an error management system, a system for storing events or sending notifications if there were errors. We do this by storing all the events in a distributed non-SQL database such as Apache Ignite. Then we have consumer applications subscribed to this error notification as well. This is the last of our 8 lessons learned. Finally, what we have done is that we have put all these recommendations in a final slide that shows a recommended reference architecture of our digital decoupling approach. And at last, what we have done is that we have added a slide with all the reference that we have used in these presentations. These references are useful for extending your knowledge in the topics that we have covered here. Goodbye, and thank you for your attention.